This video provides an introduction to the Arduino Integrated Development Environment, or IDE, on your Linux OS laptop. So the first thing that we want to do is go to the menu at the lower left-hand corner of the screen. And we want to select Programming and then the Arduino IDE. Click on that and we start things up. Takes a little bit of time, but not too long. A window will open. So here it is. Let's examine the various parts of the window. First, we see a title at the top. Here it's blank. Okay. This is the name of the program that was opened up in this window. The program is a set of instructions that we want to send to the Arduino that we've saved away. Okay, this was something that was pre-saved, so it's likely then the first time that you open the IDE, this is what's going to pull up, is a file entitled Blink that contains a program, a set of instructions. In the Arduino environment, the programs are called sketches. So this is a sketch, the Blink sketch. Something that comes along with having an Arduino. It's built in. So we have this name that's at the top, okay, and if we wanted to, oops, we don't need this, do we? Okay, if we wanted to come up with our own, we could go up here and select File from the gray toolbar at the top and say, well, we'd like to write a new one. Okay, and if we do that, another window will pop open. So let's look at this one. This one is entitled Sketch, and then the rest of the title after the underscore is today's date, November 13th, and then followed by an A. So if I open another one right away today, it'll be called Sketch November 13B, and then so on. Now the thing is that this is just the working title of this file. I would have to save it, come over here and actually save it in order for it to be saved under that name. Okay, so I'm not going to be working with this right now. We'll go back to this in a little bit. Okay, so back to this. Oh, can I get it to go away? Okay, let's go back to this. Now, you know probably that you can use the cursor to resize the window. You just go down at the lower right-hand corner and pull on it. Okay, so I'm going to make that bigger. But the thing I want to focus on after the title bar is this bar here. Just going to look at a couple of these things. So File is where we would make a new one, a new sketch, open an existing sketch, open a recent sketch. The only one that I've looked at recently is Blink. Okay, and then we have a sketchbook where we put our own sketches. Right now there's nothing in there. Okay, and then this is important. This is examples. Okay, if we want to pull up an example, a sketch that was written already by somebody else that's provided for instructional purposes to you, the user, and you can go here for examples, and then these are the built-in examples. Okay, so under Basics, you see Blink is the third menu item. So if you ever want to get back to Blink, that's the way you can do it. All right, so let's go back now and look at the menu, the primary menu here. Okay, we have Close, like you can close a window. You can always close a window by just hitting the X over here in the upper right-hand corner. Also, we can save it out. We can save it as a new file. Okay, we could print it. We're not going to be doing that right now, but those are different ways that you can use it. Okay, these are all different commands that we can use within the IDE to open, close files, quit out of the IDE, and so forth. And then on the right side of the menu, on the right side of the menu are all the keystrokes that go along with those commands. All right, so having looked at that, so that's the file area. The next thing we want to look at is Tools. Okay, now in Tools, you'll see that there are some things here that talk about the actual physical stuff. Okay, so the first thing we want to consider is the board. This is where we specify which particular Arduino we're using. In this case, it's the Nano. So mine is set to Nano, yours might not be. So make sure you go to Tools and select Arduino Nano. Okay, it might be set at Arduino Uno or some other thing. So here you see the menu. There are lots of different Arduinos that you could be using with this IDE, but the one we want is the Nano because that's the hardware that we have. The next thing we want to look at is port. Okay, down here you should see some ports. The ports are the places where we can connect to other devices to use for input and output. So right now I have 4 serial ports that have been identified as things that I can use to connect to this, but that's not really what I want. What I want to do is take that blue mini USB cable and connect that to the Nano, and then connect it to one of the USB ports on this computer. So right now I can't select a port because the USB port isn't listed. So I'm going to go out of this menu. Actually, it doesn't really matter. I'll just sit here with this, okay? And now I'm going to go and connect. I'm going to connect my USB cable. So I've got the, you can't see this, but I've got the blue cable now connected to one of my USB ports. Its other end is connected to the Nano, and I see 2 red lights on the Nano. Okay, one of them is the POW LED on top of the Nano. It's just a steady red light, and the other one is blinking. The one that's blinking is the LED marked L. Okay, if you don't see one blinking, that's okay, but you should see the POW light, the power light, on, meaning that your Nano is receiving power through the computer. Now I'm going to reselect Tools, and then I'm going to go to Port, and now I see that I have 5 serial ports listed. I need to always explicitly select my serial port for this. It's ending in USB 0. Now it's possible that you have one that ends in USB with some other digit, but you should see one, okay? And we just select that one, okay? The other thing I'm going to mention while I'm at it is when we look in the Tools menu, there is another thing, the processor, that we want to pay attention to, okay? There are 2 possible processors that can work. If you are unable to get your sketch to compile, to work, okay, to upload to your Nano, it's possible that you have to change your processor away from AT Mega 328P to AT 328P old bootloader, or vice versa. One of those 2 processors should work for you. Probably the one that's already there will be fine, but if you've tried everything else, like making sure your connections are correct, and nothing is working properly, then try that, okay, switching to the other processor, okay? I would say that was kind of a last resort. And then if you still can't get stuff to work, then you need to come and talk to me, and I'll help you figure out what's wrong. At any rate, once you select the Nano and you select the port, the USB 0, you should be good to go, okay? So now that we've done that, we want to talk about the sketch, okay? The sketch, as I mentioned, is a set of instructions that we send to the Nano. So the idea is that this set of instructions that's here, I can upload it, send it to the Nano, and that will be its instructions for how it's supposed to function. There can only be one sketch that's uploaded to a Nano at a time. So if there's a sketch there already and you decide to upload another one, it's going to replace or overwrite the one that's there. Okay, and that'll be the one that it will execute. So now let's talk about the details of the sketch. I'm going to expand the window and we can talk about this a bit. Okay, so I've made it a full screen and I want to talk about this in detail. The first thing that we'll notice at the top, oh, I should mention, this is a window that you can edit. You have a cursor and you can place the cursor pretty much anywhere you want in the window, and if you've ever edited a Word document or used Google Docs, the editing is done pretty much in the same way. So if we look at edit, the commands that you use here for, well, I don't know if they're shown here really, but for cutting, yeah, cutting and copying and pasting text are the same. All right, you can find things also using Control F. Now, having said that, so that's how you would navigate around the file. So having said that, let's talk about the structure of this file. You'll notice that the first 2 characters in the very first line are / followed by an asterisk. And then further down at the bottom of this window, just happens to be visible at the same time, is an asterisk followed by the /. So the reverse set of symbols. Everything in between, all of the text in between that I will highlight here, that is all comment. It is ignored by the Nano when we send the compiled file up to the Nano. When we upload the sketch, this stuff is skipped over. So this is text that's included for the author of the sketch and anyone else who wants to use it to understand what's happening. It's English language that gives kind of the big picture of what the sketch is about, any information about the sketch that's important to know. It's documentation. Okay, so the first thing you see right after the symbol that begins the comment field, because this is an introductory comment field, is the word blank, which is the title of the sketch. So that's good programming practice to put in the title of the sketch. And then immediately after that is a very brief description of what the sketch does. Okay, so here, what does the sketch do? It turns an LED on for 1 second, then it turns it off for 1 second, and then it just keeps doing that again and again. Okay, so that's why, you know, we can get this. We can get an LED to flash. All right, that's the purpose of this sketch. Now after that is some text that we're going to go back to. It's more explanatory stuff. This next block of text is there because this is an instructional sketch, but we're not going to look at that right now. We'll go back to it. Okay, I want to next highlight the part of the introductory comment here that gives the date it was written and modified. Actually, these are all modifications and who the authors were. So it's also good programming practice to just say who wrote it. Okay, right after that is a sentence that explains that it's in the public domain. The sketch can therefore be used by anybody. No royalties are paid to the authors. You can modify it if you like. It's no big deal. Okay, that's just to let you know that you're free to do that. Because programs are intellectual property, and so you have to be respectful of people's work and whether they should be compensated for what they do. But this one is in the public domain for instructional purposes. So this next thing here just tells you a place where you can go to get more information about the blank sketch. Okay, but we're not going to look at that right now. All right, that's stuff there's a lot of extra language in this introductory comment block that if you were to write a program, you wouldn't need to include. If you were writing a program, you should put in the title. You should put in a brief description of what the sketch does. You can put in your authorship, and that would pretty much be all you would need to put in the introductory comment block. There are other ways to include comments. Anytime you want to include a comment where you're just explaining something about the functionality of the sketch, and that might be worth doing, okay, because the sketches are not always easy to understand. You just need to write 2 slashes, 2 forward slashes in a row, and then to the right of that, all the text that's there is comment. So you can start a line with this comment marker, okay, like this line here. Okay, right after is a comment line. Everything on that line to the right of the double slash is a comment. Or you can put it in some other column, like here. Here's an example of a comment. In this case, everything to the right is a comment, the slashes, but everything to the left is not. Everything to the left is actual code, okay, instructions for the Nano. So those are a couple of different ways you can write comments. You'll notice that the comment block at the beginning that's offset by the slash asterisk and asterisk slash is all in gray font. That's the color. And then you'll see that other code in here is different colors, and that's part of what the IDE does to what we write, and it's to help us to avoid making mistakes in writing the code, to understand its structure, to be able to identify the functionality of the different parts. Okay, so let's go through this now. After you have the comment, there are actually 2 functions in this sketch. The function names are written in green. So one of them is called setup, and the other one is called loop. Whoops, loop. Okay, so the idea with these is when we have a function, it has a certain structure that we have to follow in order for it to work. Besides having a name, we have some other syntactic elements here that we must include. When you think about functions, okay, I'm just going to type one up here because I just want to type it. Let's say you have a function You probably saw this in algebra class. I'm just typing it so you can see it. You have f of x equals x, and I'll just say, I'll write it like this, x times, whoops, x, not z, okay. Let's say it's x cubed, okay. I'm not able to write exponents easily here, so I'm just going to write it like this. So we have x times x times x. So this is what the function does. So when you have a function, you have to give it a name. In this case, the function that I'm showing you right now, the name of it is f, okay. And then it has this variable that's inside parentheses. So you always, with a function, have parentheses, okay? And inside the parentheses, there are the things that we call arguments. This is information that we pass to the function as an input to the function that helps the function produce some kind of result or output. So the action of the function in this case is to take something that we're calling x here, and you would expect that it would probably be a number. It doesn't have to be, but likely it'll be a number. And what is the action the function takes? It takes that number that we pass to it, and then it cubes it. And that is the value of the function, okay? So here, if we pass x in the place of x, we put 2, then the function will have the value of 8, right? That's pretty clear. And if we pass some other number, it'll have a different function. So we have the same kind of structure when we have functions in computing. So we have the name of the function. So in the case that we showed, it was f, and now down here, the first function that we have is setup, and then it's followed immediately by parentheses. But you'll see that there's nothing inside the parentheses, and that's because the setup function does not need an argument to execute. Many functions do, setup does not, but we still have to include the parentheses. The same is true for the loop function. The parentheses follow the name of the function, but there is no argument inside. Okay, that's how these particular functions operate. So you'll notice I didn't talk about void over here. Okay. Void has to precede this function. There always is, when we have a function, some kind of name given to it at the beginning that tells something about the function. Okay. In this case, void is telling us that there will be no result returned from this function. It will do things, but it will not return a value. That's why there's void here. So we don't expect something to be returned back to the program, back to the sketch. So we have void. The word void has to appear in both cases. You have to have it there, or else the function will not work properly. So we'll notice that the word void is written in blue in both places. Okay, and you'll notice that there's other text written in blue as well. These words written in blue are reserved words. The Arduino is programmed, we program it with a dialect of C++. Okay, it's a specific set of commands within C++ that we can use that work for the Arduino. Not the complete language, but many of the commands. These are reserved words. We're not allowed to use them for any other purpose besides the ones that are specified within this environment for the Arduino. So you can't use output, the word output, to mean anything besides what it's specified to mean here, which I'll explain in a minute. High, low, and LED built-in, and the word void. Okay, those are all reserved words. So don't try to use them for anything else besides what they do here. The orange, those are other functions that are also provided, already defined within the environment. So we'll be using those. And they have to be written as they are here. So for example, pin mode, you'll see that pin mode is written so that it has a capital M in the middle. It's all lowercase except for that one capital letter. Same for digital write. We have to write these as they are. Can't change the case. Okay, can't make the M lowercase in the middle here, or else it won't work. Okay, so this is how we have to do things. So let me go back to void setup. Okay, so we have void setup. So we have the void at the beginning, we have the setup, we have the parentheses, and then it's immediately followed by an open curly bracket. and I put the mouse right next to that open curly bracket, and then I see that a closed curly bracket further down is highlighted. That is the closing bracket that corresponds to this opening bracket. So we keep these together, and everything that's contained inside is the contents of this function, the setup function. That's where the commands are. We have to have both curly brackets, or else this won't work. If I put my cursor next to the closed one, it highlights the open one. So it shows the pairs, and that's very useful in programming because lots of times if we make an error, we forget something. We leave out a bracket, we have too many brackets, something like that, some little detail. So here, within this function, you see there's a comment, okay, which of course is going to be skipped right over. It's for us to read, okay, and then there is only one command, this pin mode command. That is the complete contents of this setup function. So if we look down at the loop function, we have the same sort of structure. It has an open bracket, and then that's followed by 4 commands: digital write, delay, digital write, and then delay again. You'll notice that each of the commands that's listed within each function terminates with a semicolon. The semicolon must be there. It indicates that the function, that the command is finished. Okay, it closes out the command. You have to include it. These are, as I say, little details that we have to remember to include, or else it's not going to execute. Okay, so the way this works is the setup function is executed once. It's doing all the stuff we want to do at the beginning to just initialize things, okay? And then it's followed by the loop function. The loop function is set up like this. Whatever's within a loop function is executed sequentially. So here we have 4 commands that are executed one after another, 4 instructions, and then when we get to the last one, we go back up to the first one and execute it again, and then the second, and then the third, and then the fourth, and we go back to the top and execute again, and so on and so on. It's an infinite loop. That's why it's called a loop, okay? This is going to continue to execute until we stop the power to the Nano, okay? That's how this works. So now you can understand why you want to maybe set stuff up at the beginning, initialize some things, and then you go into loop mode, right? And the way this sketch works is we have initialization, and then the loop executes makes a light blink, okay? It turns the light on, and then turns it off, and then turns it on again, turns it off, and on and on and on, okay? That's how this is structured. So the individual commands. Okay, so we have this thing, pin mode. I mentioned before that the Arduino has pins on it. So the actual physical Arduino has these little metal legs sticking out of it, and the tops of those legs protrude slightly through the board. So you can see where the pins are on the top because you have these little very, very small protrusions, a whole line of them along each side of the board. And they're labeled in very small writing so that we can tell them apart. They have all different kinds of labels on them that we'll be talking about in later classes. This helps us to identify which is which. One of these are called pins, okay? They act as ports. They allow us to connect things, peripherals, to the board. One of the pins is linked to the LED on top of the board that is labeled L. And the pin that's linked to the LED on the board, that's L, the L LED. Which one that is depends on which Arduino we have. All right, so with the Nano, the particular pin that's linked to that is pin 13. It's labeled on the Arduino as D13. Okay, so if you look at your Arduino, you'll see that it is very close to the place where we connect the Mini B USB cable. Okay, it's in fact the top pin closest to the connector spot. So that one is linked to the LED on top of the board. But with other Arduinos, the particular pin might be some other pin. So instead of putting the pin number directly in this function, To make this sketch more general, we just use LED built-in, okay? And because we've specified in hardware that we're dealing with a Nano, then the sketch will do the right thing. It will identify the correct pin as being the one that we're talking about, and will adjust and use the proper pin. So that means that the script can run for any Arduino, even if it's a different pin number that we would use. So we mentioned the LED built-in frequently. Now you could, if you wanted to, just change this to 13, all right? But then your script would only run on the Nano, right? And possibly an Uno or maybe some other Arduinos that use pin 13 for the same purpose. But let's for now just leave it LED built-in because it works fine. Now pin mode. What we're doing in this setup line is we are specifying that we want that particular pin to be an output pin, meaning we're going to be sending information out of that pin, okay? And so the first argument for the pin mode function is the pin number that we're interested in, and then we're specifying its mode, its particular mode, as a second argument. In this case, we want it to be an output pin, okay? And that's in fact what the comment says just above it, okay? Now the loop function, we want to do things now with this. Digital write means we're going to dictate what the value is, or basically what the voltage is at that pin. And so we're telling the LED built-in pin, in this case it's pin 13, that we want to set it to high. Now high for the Nano means probably 5 volts, approximately 5 volts, but we're not specifying that, it's just high. Okay, high means 5 volts. It might be a little less than that, but it's going to be something on those lines. So when you have this kind of specification that's digital, all we specify is high or low, on or off, okay? That we don't go to anything more specific, okay? So all this means is turn on the LED, okay? That's effectively what this means, turn it on, okay? Then immediately after that, we have a command that says delay. Now you'll see delay, that means don't execute the next statement right away. Just wait, okay? And you see that the argument here is 1000. This is actually in milliseconds. That's the time in milliseconds. So this means, 1000 milliseconds is 1 second. So it says wait 1 second before executing the next command. The next command after that is one where we want to make the LED turn off, okay? And we do this by sending digital write. We send to this particular pin that we want low, okay? The value low just means 0 volts or approximately 0 volts. So either high is on and low is off, so now turn it off, okay? And then again, wait 1 second. So on, wait a second, off, wait a second. And then go back to the beginning. On, off, on, off. Now, you might wonder why we have this delay in here. The reason we have the delay in here is because these statements execute so rapidly. I believe that a typical command within this environment will execute in 6 microseconds. I could be wrong about that, but I think it's something like that. So if we don't have the delays in here, it's going to execute so fast we're not going to actually see the blinking. So this allows us to actually witness it. So we can take this function, it will just keep executing and executing and executing, okay, after the setup until we break off the power. So this is the script, this is the sketch that we want to send to the Nano now, and this is how we do it. When we have the sketch set up and we think it's pretty much ready to go, we can click on this button here with the check mark on it, and you see as I highlight it in white text to the right it says verify. So what this step does is it checks over what we have in the sketch and makes sure that all of the commands are legitimate, syntactically allowed commands. And so what this is going to do is it's going to find problems, like if we don't have semicolons after all of the commands, or we leave out a curly bracket, or we write one of the internal commands incorrectly, it will tell us. And so and if everything is okay, what it's going to do is take the code that we wrote, and it's going to convert it into a different form that is more difficult for us to read but easier for the Arduino to read, and that's called the compiled version of the code. So the compilation takes place, and we see comments from the compiler that are displayed in the bottom window. Okay? And if the compilation is successful, we'll just see white writing down here. If there's a problem, it'll be orange and it will contain errors, and that means there's a problem. We have to go back into the sketch and figure out what we did wrong. When we do the verification step here, the compilation, it worked fine, which is to be expected since the only modifications I made were I put in this f of x equals x times x times x, but I put that in the comments, so that's the only change I made. So it should work, right? Because this is a sketch that was already there, that was in the public domain and has been tested many times, so it's fine. The next step is to upload this compiled sketch to the Nano. So we do that. I click on that. Okay, again, we're getting comments down here, and it seems all fine. Okay, and now you just wait a moment, and then when you look at your Nano, you should see that L light blinking. Now you may have seen the L light blinking before, and that is probably because the blink sketch had already been loaded onto your Nano. We're receiving them now with the blink sketch already on there. So some Nanos anyway do have it on there already, so but you're just overwriting the same sketch, and that shouldn't be a problem. Okay, but you should be seeing the L light blinking on, off, on, off. Okay, and it should be 1 second at a time. Now let's make a change to the sketch and see what its effect is. So if we go down here, we have the digital write with the delay. I'm going to change the delay for the on portion. Okay, I'm going to change it to 3 seconds. Okay, that's the only change I've made. And I'm going to compile this, and I don't expect to have any problems at all because the only thing I changed was that one digit. And then I'm going to upload this to the Nano. And now as I watch it, I see that the on period for the L LED is a lot longer than it was before. Okay, so it looks to me like it worked fine. Okay, and it's doing exactly what I wanted, which is great. When I made this change, I didn't save it. You don't have to save it out. You can just compile and upload as you experiment. Okay. Now, once I've made a change that I really want to save, I could come up here and save it in the file. Now, I wouldn't recommend saving this under the blink sketch. I would say if you really want to save something, you would save it under a different name. Okay, that's something you can do. So that's how the blink sketch works. Now, if I go back to having this be 1000 as it was before, I see that I have a blinking light, and it takes 2 seconds for it to go through its full cycle of on and then off. Okay, so it takes 2 seconds to execute one cycle. It's one cycle every 2 seconds. So that means in 1 second I execute half a cycle. The number of cycles per second can be expressed as hertz. You may have heard of that unit before. Hertz is cycles per second. So the blink sketch as it's written allows the Nano to blink with a frequency of 0.5 hertz. Okay, and I'm telling you this because this is important for the assignment that you have to do, where you have to modify the blink sketch and have it blink with a different frequency. Okay, so keep that in mind, and when you write out the sketch, remember that that is what you have to account for, the cycle being both on and off to have a complete cycle. Okay. All right, so I had said that I wanted to go back to talk to you about the template that came up, the other file. So I'm going to close down the blink sketch and open the other one. This was the other one. So this is the sketch that opens by default. All right. You can always do a new sketch, and this is what you're going to get with the date at the top. And I can hit return like this, and I can insert stuff up here. Like if I want to put comments in, I can put comments here. Okay, I can come down here and put my code in here, my setup code in here. I can put the main code that I want to have in here that I want to have run as in a repeated fashion in an endless loop. And this is a template that's good to work with when you're writing your own sketches. You just put the commands within the curly brackets. You're going to want to put comments in, absolutely, because if you don't comment your code, other people will have a hard time reading it unless it's extremely, extremely simple. And you yourself may forget what you wrote. You could write a great program, a great sketch, and then put it away and come back to it in a month, and if it's not commented, if there's no documentation, you may not remember what it does anymore. So this will help you. You won't have to keep track of all this. It's all written down. When we save out a file, it's best to not save it with the name that's given to it as a placeholder by the IDE. It's better to save it as something else. Give it a name that indicates what it does. Otherwise, it's going to be hard to remember what it does. Okay, so that is the end of what we're doing here with the Arduino. There'll be more to come in class. There are assignments on Canvas for you to look at and so hopefully this will help you to do the assignments.